So figure 1 shows a plot of part of the curve with the equation y equals cos x, where x is measured in radians. Okay, so I'm just going to stop there quickly. And whilst we're here, we can see that we've got y equals cos x on figure 1. So I'm just quickly going to label this on figure 1 before I forget. So look at part A. It says use diagram 1 to show why the equation cos x minus 2x minus half equals 0 has only one real root, giving a reason for your answer. So you can see it says to use diagram 1. So we're going to have to graphically show this using diagram 1 somehow. But we also need to give a reason for our answer. So we're going to need to use some words to explain it as well in order to get the 2 marks for the question. So we've been given the equation here. And we're just going to have a quick look to see what we can do with that and see if we can manipulate it anyway. So the first thing that jumps out to me is that we've got the minus 2x and minus a half. So if we rearrange the equation, we can say that cos x equals, if we add the 2x and add the half, we've got equals 2x plus a half. Now we could look at this and think of this actually as 2 separate functions of y. So we can say that y1 equals cos x and y2 equals 2x plus half. And think of these as 2 separate functions. When we equate the functions, so set them equal to each other as we've done here, the point of intersection of them graphically on the graph will be solutions to the equation. So if we only get one intersection between both these functions of y, then we know this equation will have only one real root. However, if it has more intersections, then we know there'll be more real roots. So for example, 2 intersections will mean there are 2 real roots. So what's great is that we've already got the function y equals cos x graphed out here. So I'm just quickly going to edit this to make it a bit clearer. So we've got the y1 equals cos x. So now we're going to plot y2. So if we think about this quickly, we can do a couple of points to help us. So if we sub in x equals 0 to give us the y-intercept, we get that y is a half. So if I just plot that on here, and then working down here quickly, we could also work out the x-intercept. So if I say set y2 equals to 0, we get 0 equals 2x plus a half. So we say 2x equals minus a half. And then x equals, so if we divide both sides by 2, we get minus a quarter, like that. Brilliant. So I'm just going to plot that on here, sort of roughly about there. So that's great. So now we've got these 2 lines. I'm going to try drawing y equals 2x plus a half. So if I do that, we get a line something like that. Now I'm just quickly going to label it on so it's easy to remember. Now one of the checks to make sure we've sort of roughly done it right is we can see here we've got a positive gradient of 2, which matches up with the line we've drawn. So as I mentioned earlier, the points of intersection will be the solutions to the equation. And we can see here we've got one single point of intersection here, which means we only have one real root. So we've used diagram 1 to show this, but now to get all the marks we need to give a reason for our answer. So down here I'm going to write an explanation. So since there is only one point of intersection between the functions y1 equals cos x and y2 equals 2x plus a half, it follows that the equation cos x minus 2x minus half equals 0 has only one real root. So looking back to see where we get the marks, we get 1 mark for drawing a graph like this. And then we get the second mark for an explanation like this. But the key points you need to include in the explanation is that there is only one single point of intersection in order to get both the marks. So what we're now going to do is work on part B. So it's given that the root of the equation is alpha and the alpha is small. Use a small angle approximation for cos x to estimate the value of alpha to 3 decimal places. And remember to 3 decimal places because it often specifies in questions how they would like that answer. And you could lose silly marks for writing it in the wrong form. Okay, so looking back up at part A, we can see we're given this. So we're going to use this same expression again to estimate the value of alpha. Now from the formula booklet, we know that the small angle approximation for cos x is that cos x equals 1 minus half x squared. So what we can do, we can use this sub into the original equation, or the one from part A. So doing that we've got 1 minus half x squared minus 2x minus a half equals 0. So it's great because look at this, we can start to see that it's a quadratic. Now before we solve it, we can tidy it up a little bit. So if we take away the half from the 1, we get minus half x squared minus 2x plus a half equals 0. And tidy it up even further, if we multiply by minus 2, we get x squared plus 4x minus 1 equals 0. Now what we're going to do is solve this. So these sort of questions aren't trying to test your ability to solve quadratics. So we don't need to be worried about trying to use the quadratic formula perfectly. We can just put it into our calculator to get the solutions. So putting this into the calculator, we get that x equals minus 2 plus root 5, and x equals minus 2 minus root 5. But here's where questions sometimes often try and catch you out, because here we've got two solutions. However, we know from our work in part A that the equation has only one real root. So we can have only one value for x. So now we need to work out which one to reject and which one it can't be. Well, looking back at our diagram at the top, we can see, so this is where it intersects, so this is where the solution is. And we can see this gives us a positive value of x right here. So we know that this value of x we can reject. So it's always good to still write it down, but just say that we reject it. So therefore, the root, or as it calls it in the question, alpha, is approximately equal to, and remember it says in 3 decimal places. So again, using our calculator, we can see that it's approximately equal to 0.236 to 3 decimal places. And that's the answer to the question. So looking back to when we get the marks, we get 1 mark for this step here. So using the small angle approximation and subbing it into the equation. And we get the second mark for attempting to solve this quadratic equation. Then we get the final mark for getting the correct value for alpha.